been 4 decades of a long journey, but now the Voyager 2 spacecraft has finally bid farewell to our solar system.
Voyager 2, the intrepid spacecraft launched by NASA in 1977, has stunned scientists with an encounter that defies the boundaries of current understanding in deep space physics. For nearly 5 decades, it has traveled far beyond the outer reaches of our solar system, cutting a path through the vast, silent interstellar medium. Its sensors, delicate instruments forged in the technological language of the late 20th century, have long exceeded expectations. Yet nothing in its historic journey could have predicted what unfolded in the cold, uncharted depths over 12 billion miles from Earth. Before we start, smash the like and subscribe buttons for more updates. The spacecraft, drifting steadily through the interstellar void, transmitted data from an encounter so unusual that it has forced researchers to question the limits of astrophysical models. On a routine data sweep, Voyager 2 passed through a region of space previously thought to be stable and empty. Just sparse particles, cosmic dust, and the ever-present whisper of interstellar plasma. But the spacecraft registered a sudden and violent fluctuation in magnetic fields, a distortion so intense that its instruments temporarily scrambled. This was not a mere blip or technical anomaly. The data was consistent, repeated, and unmistakable. Voyager 2 had brushed against something unknown, something that does not belong in the conventional map of deep space. The source of this magnetic chaos was neither a black hole nor a solar remnant. There was no nearby star or remnant nebula. There were no high-velocity particles from a supernova, no gravitational lensing to suggest a mass anomaly. Instead, what Voyager 2 encountered was an inexplicable localized pocket, a bubble of extreme magnetic turbulence. It was as if space itself had momentarily warped, coiling into a tightly bound storm of invisible force. The spacecraft's magnetometer picked up fluctuations orders of magnitude higher than expected, while the plasma wave instruments captured irregular, pulsating energy spikes, signals without precedent in its 47-year voyage. The implications ripple out in all directions. If such a disturbance exists this far beyond the heliopause, the boundary marking the end of the sun's influence, then our understanding of the interstellar medium may be drastically incomplete. Until now, scientists believed that beyond the heliopause lay a relatively stable environment, a kind of galactic wilderness populated by sparse hydrogen atoms, slow cosmic rays, and a weak uniform magnetic field carried from the galaxy itself. Voyager 2 has revealed something far stranger, a reminder that deep space is not a static desert, but a dynamic, shifting ocean of forces we are only beginning to grasp. There are several factors that make this encounter so astonishing. First is the scale. The anomaly wasn't brief. It lasted for several hours of real-time transmission, suggesting that the spacecraft traveled through an extended region of this mysterious turbulence. That implies a structure at least several thousand kilometers across, floating in the interstellar dark like a ghost storm. Second is the sheer power of the fluctuation. The magnetic field in that region spiked to values that would normally only be observed near strong stellar bodies, yet here there was no mass, no light, nothing but vacuum and magnetism. Speculation is inevitable, and theories abound. One posits that this could be a remnant of a long-dead star, some fragment of a collapsed system where magnetic fields have congealed into a coherent, if invisible, structure. Another suggests that this is a magnetic reconnection zone, a place where galactic field lines break and reform, releasing vast amounts of energy in the process. That would be similar in principle to solar flares, but on a scale never before observed outside a stellar system. More exotic theories propose interstellar filaments, tendrils of energy that weave through the galaxy, remnants of its birth or indicators of processes still unknown. Perhaps Voyager 2 crossed one such filament and for a fleeting moment touched the unseen scaffolding of the universe. What complicates the matter further is the nature of Voyager 2's instruments. They are analog, not digital, built with 1970 S-era circuitry and software. That such a system could even detect and transmit data from this anomaly is a testament to its engineering, but also raises new challenges. Interpreting the raw data requires sophisticated modeling and deep inference. Despite the limitations, however, the signature of the event is clear. The anomaly left a kind of footprint in the magnetic data, an unmistakable oscillation pattern unlike any recorded in solar or interstellar observations. Adding to the mystery is the behavior of surrounding particles. Voyager 2's particle detectors showed sudden changes in the velocity and density of charged particles in the vicinity of the disturbance. Particles that should have drifted smoothly through the void suddenly accelerated, as if pushed or pulled by an unseen hand. This hints at the possibility that the magnetic anomaly was not just a passive field, but an active force, an energetic structure capable of influencing matter at a distance. If confirmed, this would suggest the existence of energy systems in deep space that are entirely decoupled from matter, governed instead by magnetic and plasma dynamics. There are no known natural phenomena that completely account for this behavior in such a region. Even the galactic magnetic field, which stretches across the Milky Way like a thin net of influence, doesn't possess the intensity or configuration necessary to cause what Voyager 2 encountered. Some scientists have floated the possibility of a dark plasma structure, an energetic form not bound by traditional matter but existing as a concentrated pocket of force. Others have even entertained more speculative interpretations involving transient phenomena or rogue waves in the electromagnetic field of the galaxy. The broader implication is unsettling. If Voyager 2 can encounter such a region, then these anomalies may not be rare. They may be scattered throughout the galaxy, waiting in the dark, exerting unknown influences on cosmic structure and the flow of matter. Could such phenomena shape the trajectories of rogue planets or interstellar objects? Could they explain the erratic paths of some comets or the strange accelerations seen in visitors like Oumuamua? These are questions that suddenly become urgent because the cosmos may be far more dynamic and chaotic than the pristine void we once imagined. Moreover, the encounter raises questions about how we define empty space. If vast regions of the galaxy are filled with invisible energy zones, then the interstellar medium is not merely a passive backdrop, it is an active participant in the evolution of cosmic structures. The magnetic anomaly could serve as a kind of galactic weather system, influencing how particles move and interact over immense distances. This also hints at potential dangers for future space missions, especially those involving crewed travel beyond the solar system. Unpredictable magnetic zones could interfere with electronics, cause dangerous particle fluxes, or even damage shielding in spacecraft. Another avenue of thought veers into cosmology. Could this be evidence of topological defects in the fabric of space-time itself? Structures like cosmic strings or magnetic monopoles have been theorized but never directly observed. The characteristics of this anomaly, its intensity, size, and sudden emergence, do not completely rule out such interpretations. If true, Voyager the 2nd of May have passed through a fragment of the early universe still lingering in the present, a leftover thread in the cosmic tapestry. What makes this all the more compelling is the solitary nature of the witness. Voyager 2, a lone machine billions of miles from Earth, is the only source of this data. There is no backup, no second angle, no other spacecraft in that region to corroborate or contradict what was sensed. Its instruments, though resilient, are aging, and yet they managed to transmit this signature in a whisper that traveled hours before reaching Earth. That whisper, encoded in radio waves, now contains one of the most intriguing clues yet about the unknown forces that govern our galaxy. As data continues to be analyzed, it's clear that this is not just a curiosity, but a pivotal moment in space exploration. Voyager 2 has not merely provided a snapshot of an anomaly, it has opened a doorway into an entirely new kind of deep space environment. This may herald a paradigm shift in how astrophysicists model galactic structure and energy dynamics. The assumption that interstellar space is a passive, predictable void has been shattered. The reality is far stranger and far more volatile. It also brings renewed urgency to the development of next-generation space probes. Instruments capable of high-resolution mapping of magnetic fields, plasma densities, and gravitational anomalies are now more vital than ever. Missions like Interstellar Probe, still in conceptual phases, may need to factor in such unpredictable anomalies. What Voyager 2 encountered could be the first of many, and without modern instruments prepared to detect and analyze such phenomena, we may be flying blind into regions of the galaxy more dangerous and more wondrous than we ever imagined. a final surge of revelation from the edge of human reach. It tells us that the cosmos is still full of secrets, and that sometimes the most profound truths are found not in the brilliance of stars, but in the quiet turbulence of the void. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on Voyager 2's impossible deep space encounter? We want to hear from you. Thank you for watching and see you next time.